Okay, so good morning. So today we're going to solve another problem in chapter 9, the 9.7, problem 9.7 in the book of Ken Black, the business statistics for contemporary decision making, 6th edition. Okay, so this is our problem first. If you already read the problem, please pause the video and try to solve the problem on your own in order to check if you really understand how to solve this problem. So before we start, what we're going to do, we have to draw the Raymond framework. Okay, and then every time you read some values there, we have to put it in our framework. Now, let's start reading. A manufacturing company produces a valve in various sizes and shapes. One particular valve plate is supposed to have a tensile strength of 5 pounds per millimeter. Tensile is the force exerted if you stretch a material. Okay, and then the opposite there is the compressive strength. Okay. So the company tests a random sample of 42. So that's the 5 pounds per millimeter. That's the standard. It's the company standard. Should have a tensile strength of 5 pounds per millimeter. And then a sample size of 42 valve plates from a lot of 650 valves. So that is our population size. So the sample mean from these 42 tensile strength is 5.0611, so I already round off that one. I'm not very particular with decimal points in these kind of problems. Okay, and then the population standard deviation is 0.283 pounds per millimeter. Use a 0.10 confidence level and test to determine whether the lot valve plates have an average tensile strength of 5 pounds. Guys, take note. The standard here is 5 pounds per millimeter. And then we got a sample of 42 from this 650 and we average the tensile strength. That is 5.06. This is different from 5 pounds per milliliter. But the question is this 5.06 significant different from this 5 pounds here? It is very important. Okay, so step 1, we have to establish the null hypothesis. We say that the mean is still equal to 5 pounds per millimeter, and then the alternative hypothesis is not equal to 5 pounds. So we can already see that what we are dealing here is a two-tailed test. Okay, since we cannot see less than or greater than in the problem. Okay, in step 2, determine the appropriate statistical test. Since the population size is given and then the population standard deviation is given, we're going to use this formula here with a finite correction factor. Okay, and then set the alpha value. The alpha value is already given, the 0.10. Okay, and then the 0.10 is divided by 2 because this is a two-tailed test. That is why the 0.05 here and then the 0.05 here. You have two options. You can look at the z table for the value of the 0.05, or you can simply look at, you can memorize formula that we mentioned in the previous videos. Guys, if you have not seen the video, please watch the video in chapter 8. Okay, so using the critical value method. So this is the decision rule based on this 0.10 here. Okay, so that's 0.05, negative 1.645. Okay, just for the discussion purposes, we're going to look at the z table. 0.05. The z table here, 0.05 is around here. You can use this one, so that is negative 1.64. Okay, approximately similar result here. Okay, so another way is to use the critical value method. So the formula of the critical value method is we're going to use this formula here, and then we will just replace the sample mean here by xc to specify that this is the critical values. And then, okay, so there is a trick here. If you really like algebra and you really want to solve this one, you can also do that. But if you want to maximize the use of calculator and avoid mistakes such as negative signs, you can simply maximize the use of your calculator here. Okay, how are we going to do that? But make sure, guys, that you are in the mode, this first mode here. Okay, not in the stat mode. Okay, just simply write the 1.96. Okay, we have to solve the positive and negative later on, so we will start with the positive 1.96 equals. So the equals here, do not press this equals here. We have to use this equals here, the pink side here. So in order to access the pink function, we have to press the alpha and then equals. And then the fraction form, and then xc here, we have to solve the value of this xc here. So we have to solve this x. So that's pink, so alpha x, and then minus 5. Then go to the denominator. That is 2.83. I cannot see it. So that's in fraction form. 0.2803 over the square root of 42. And then multiplied here to the square root of sample size 650 minus 42 divided by 650 minus 1. And then just press equals. Oh, syntax error because that we're not going to press equal. Sorry for that. We're going to use the shift solve here. We have to access the solve function here, so we have to get the shift solve and then solve for x. You can just simply press equal here. And then our first value for the positive is 5.08. So 5.08. So 5.08, and then we solve for the negative 1.96 value. We expect that the value is 4.92. Let's go back, guys. If you already in this step, do not press AC and then try to encode again. To save some time, just use the replay here. Okay, and then replace this one by negative, and then shift solve for x, and just press equal there. So that is 4.91 or 4.92. In this particular case, the 4.92. And then, yeah, that is our decision, establish our decision rule. Next step, we have to analyze the data. Now we have to solve for the z-score, not the critical, but the z-score from our data. This is the formula here. We have to simply plug in the values here. So our sample mean is 5.06. Yan, and then 5, so on and so forth. And then our z-score is 1.46. We have to plot the 1.46 in our distribution plot. So the 1.46 is around here. And then take note, guys, this portion here is the non-rejection region. Non-rejection region. And this blue section here is the rejection region. If this line here will be in this portion here, we are in the rejection region, or we have to reject the null hypothesis. So in this particular case, since the value of our z-score here is 1.46 in the non-rejection region, and we can also have a decision like here, like this one. We can also decide based on the sample mean. This 5.06 here is within the range of 4.92 and 5.08. Okay, so you have two options. You can decide based on the z-score, or you can decide based on the mean using the critical values here. Okay. So, what is our conclusion now? Our conclusion is, since the z-score of 1.46 is in the non-rejection region, so this is the z-scores, negative 1.645 to positive 1.65, and the sample mean is in between the critical values. These two are the critical values. Hence, we fail to reject the null hypothesis. We fail to reject because our values are in the non-rejection region. This implied that the average tensile strength of the valves produced by the company still complies the standard of 5 pounds per millimeter. Okay? So, good luck and God bless.